to simulate tossing an unfair coin, which has a probability of heads of 0.55. It means 55%, and we're going to do it 5 times. It means that we're going to toss the coin for 5 times using Excel's run function or random function and counting the total number of heads that appear in the 5 tosses. And each toss must use a separate run function. So we're going to simulate 200 replications of this experiment and determine the number of heads that appear on each replication of the experiment. Your spreadsheet should show the run for each toss, the outcome of each toss, and the total number of heads. You must provide a listing showing the results of each of the 200 replications. And based on the outcome of your simulation in part A, you're going to create a PMF, which is the probability mass function of the number of heads and the associated probability. And after which, you need to compare how does the PMF created above compare to the theoretical PMF derived from the binomial distribution. It means using the formula of the binomial distribution. All right, so let's try to have a sheet here. I'm going to have a new sheet. Let me make the font bigger. So the first step is to write your replication here in the first column, like so. Okay, and here you have to specify the toss one and drag it to the right. Okay, so we can delete this. So we need only 5 tosses as mentioned in the problem. All right, so let's insert one more column here, but also we can do this later. So let's do it later for the outcome. So we need 200 simulations. So this is the first, the second. We just have to select these 2 numbers and drag it to, or drag it until you reach 200. So I'm going to select 1 and 2 and drag it until 200. So this one we don't need. Okay. These ones are not needed. So now we have 1 to 200. And for those one, we're going to use a rand function. So equals rand. Actually, this particular function generates a random probability from 0 to 1, but basically from 0 to 0.999. Okay, just hit enter. So as you can see, it's between 0 to 0.999 or 0 to 1 exactly, but usually you don't see 1 and you don't see 0 there. Okay, so just drag it down. It will keep on changing. Don't worry about this. Even if you're going to click anything there, for example, it will change or write something. It will keep on changing. Okay, and for the second one, the same equals rand. Okay, as you can see, the values keep on changing. Right, same with the third. Actually, we can just drag it, to the right like this. Okay, and drag it down. So we have now 200 times 5. So that is 1,000 simulations, as you can see here. I mean, we have 200 simulations, but we have 1,000 outcomes. I mean, as you can see here, the count is 1,000 outcomes. It's like, 1,000 random probabilities. And we have 200 replications, as you can see here. So we have 200 simulations and 1,000 outcomes. So we generated 1,000 probabilities. Now, we cannot actually work here because this will keep on changing every time you press anything or we write something in a cell. So what we're going to do, we are going to copy all of this. Okay, copy and open a new sheet and select any column or any cell there, right click, paste special values. Okay. So basically we just copied all the values generated using the run function. Now, as you can see here, we don't have any formulas anymore. So when you write something there, it will not anymore change. Okay, so it's now frozen. All right, so let's now proceed to the next question. Okay, so we are now going to have the outcomes as mentioned in the question here, that you must provide a listing showing the results of each of the 200 replications. So we need to provide our outcome. You can put it here, or it's better to put it here, after the column. So select column C and then insert. So it's going to give you one here, one extra column. All right, and here as well. So we have inserted some extra columns for the outcomes. So this is outcome 1. Okay. This one we can just copy this one here. This is 2. This is 3. 4. Okay, let's fix that. And the last one is 5. Okay, so we have 5 columns. So here we're going to identify which one belongs to head and which one belongs to tail. So it's given in the problem that this is an unfair coin. The P of head is 0.55. This means that if you're going to repeat, this particular experiment a large number of times, the P of head is going to converge to 0.55 or 55%. So it's like cumulative, So it's between 0 to 0.55. So anything within 0 to 0.55, the P of head there should be, the outcome there is head. Anything between 0 and 0.55, because our P of head is equal to 0.55. Okay, basically we have to say P of heads here because we are having a cumulative experiment here or scenario. Means we're going to repeat this particular activity a large number of times. In this case, we're doing it, in 200 simulations. So usually we don't include 0.55 because 0.55, the P of that will be 0 actually. So from a 0 to 0.55 is gonna be head. Okay, so we can include 0.55 or we can have less than only 0.55. Okay, so equals if. So we need to now identify the outcomes here in those one, whether it belongs to head or tail. Okay, so beyond 0.55, okay, that's gonna be belonging to tail, because between 0 and 0.55, this belongs to heads. So equals if, you're going to use an if function, fx, okay, logical test. Logical test is the condition. And the value if true, that is the outcome when the condition is met, okay? Or if the condition is met or satisfied. So our condition is if the probability here under TOES 1, for example, or in TOES 1, is less than 0.55 is gonna be hit. So this is less than 0.55. This is H, okay? Otherwise is value false. It means, you know, if the first condition or if the condition is not met, it's going to give you tail. That means if it is 0.55 and beyond, but usually it is, you know, above 0.55. Anyway, 0.55 is 0, the P of hitting a particular point. Okay, so H is the outcome here because 0.300 something, that belongs to this interval 0 to 0.55. Just drag it down. So this is false. Okay, so you can change that. You can fix that here by putting T here, double quotes and double quotes. Okay, and drag it down again. So that's the opposite of H. And here we can just copy this formula, Control V. So as you can see, this is H 0.13, drag it down. Okay, this is tail 0.60. Just copy the formula and drag it down. Okay, drag it down. All right, so we are done here, and try to review some values. For example, here T 0.68 is correct. Here H 0.28, 0.23 is H. Here T is 0.78. Here we have T 0.72. Okay, so we are done there. Let's now proceed to the calculation. We need to count as mentioned here. Okay, so we need to determine the number of heads here. So we need to add one more column here for the count. Okay, let me just show this properly. Okay, so I'm going to put here count of each. So we're going to count the age here per row. That is equal to count if fourth one. Okay, fx. Now select this row. Okay. And okay. After putting the criteria here, the criteria is age. So don't forget double quotes, age, double quotes, because age is a text. Okay, so there are 5, which is correct. 1, 2, 3, 4, 5. Drag it down. Here we have 3H, 1, 2, 3, because we have 3, because you have 2 T's there. Okay, so now let's have the PMF. We are done counting the age. The PMF is mentioned here, letter B. Based on the outcome of your simulation in part A, from here, create a PMF, that is the probability mass function of the number of heads and the associated probability. Okay, so let's put it here. All right, so I'm going to put it here, PMF. As you can see, there are possibilities of getting 0, 1, 2, 3, 4, 5. Yeah, even if you don't see the 0, for example, but I can see that there is 0 there, for example. Yeah, it might happen, yeah, or not, because these are randomly, extracted actually using the run function. So we know that the maximum is 5 because we have 5 doses, okay? And the minimum, of course, is 0 because there is a possibility that in a particular simulation, all outcomes are tails. There's no head. So 0 is the minimum. Then we have 1, 2, 3, 4, and 5. Okay, so again, 5 is the highest because we have 5 doses, dose 1 until dose 5, and 0 because is the minimum because there is a possibility of getting all tails, no heads in a particular simulation. So here we're going to identify first the count. Okay. Okay, how many zeros, for example? So we need to calculate this automatically. Okay, the total, of course, is 200. So to automate the process, we need to select all the cells opposite the events. Okay, the event of getting 0 head, 1 head, 2 heads, 3 heads, 4 heads, 5 heads in every row, in every simulation, for example. Okay, but here we have a total of 200. So we are now going to count all the simulations where it appears 0. That means no head in these rows. So we just have to select all so we can calculate immediately for 1 as well, for 2, 3, 4, and 5. So to automate the process, so we don't need to do it one by one and save our time, we just have to select all of this, then equals COU. Basically, whenever you perform any calculation in Excel, you need only the first 3 letters, okay? And select the required function. So we need count if, double click this, the fourth one. Okay, and fx. The range is from where you're going to count. So I'm going to count from here. So select L. And here, okay, to be safe, press F4 to lock this particular column so it doesn't change. Okay. And criteria is this column here. Okay. And okay. So as you can see here, if we're going to select this, the total or the sum is 200, which is correct. So there is only one row that shows 0. Okay. As I said, this is not always the case because we generated these probabilities using the run function, of course, which keeps on changing. Okay, so now let's have the probabilities. This one is our, okay, let's put this title above. These are the events. Okay, let's have this x equals head. And here we have p of x. The probabilities, okay, of these events, 0 to 5. So the first one equals 1 over 200 because the total is 200. And just drag it down. Okay, so the total is 1, of course, because we're adding all the probabilities. All right, so this is the answer actually. This is the PMF of this particular data. We have the count of H here, and we use count if to count every row that has 0, 1, 2, 3, 4, 5 each. Okay, so let's look at other questions here. So we are done with A and B. We performed the simulation. We had 200 replications, okay, using the run function, and we have the complete list of all the outcomes as well as the counts of the age. And based on this outcome of the simulation in part A, we created a PMF of the number of heads and associated probability. Okay, now how does the PMF created above compare to the theoretical PMF derived from the binomial distribution? So this is as per the theory. So let's look at it, okay, and compare. Okay, first one is very small. As you can see here is close also, 0.005. So this could be 0.018, so 0.02. If I'm going to round this one off, this can be 0.01, okay? Because 5 is the next there. So this is close, and here 1 is 0.11, here 0.12, 0.13, and 2 is 0.276 or 0.28, which is almost equal here. Let me just increase this. Yeah. And for 3, here is 0.337 or 0.34. Here I have 0.31. And here 0.215, approximately 0.22, and this is 0.21 approximately. And here I have like 0.06 something, and here 0.05, or this could be 0.07 to decimal places, which is very, very close. Yes, so we can conclude that okay, let me just write a comment here. The PMF generated through 200 simulations using 5 doses is very close to the theoretical PMF with minor or very minimal variations. If, okay, a higher number of simulations is generated, these values could be a lot closer. Okay, so it depends actually on the number of doses, number of simulations. You know, it can be very, very close to the theoretical values given here in a particular table. So this is how to answer this particular question actually. And I believe we have answered all of these questions A, B, and C. So thank you so much for watching. Until next time, bye-bye.